recording. Okay, so today is January 25th, and we're going to be finishing up module number 1. So last time we got started on module number 1, and we're going to continue on. So what I'd like you to do kind of as we kind of get started here, re-pull up that spreadsheet for spur gear design, the one that we had filled in the top 4 with example 9.3. So we're gonna continue using that because 9.4 is going to use those initial values, but we're going to kind of finish up, okay? And then we're going to do another problem kind of top to bottom that's going to get you a little bit more experience using that so you're ready to do the homework. And then there's just a couple more things to kind of cover, and I think there's going to be work time today. So the last time we were together, we had like the course overview, the syllabus, and then we were jumping into things, but now we're in a pretty good position so that I think there'll be time for you to work a little bit on homework, have me available if you need to answer questions and stuff like that. And then notice here at the end of our week here, assignment number 1, it's going to be its due date, and then practice problems for number 1 as well, module number 1. So that's the gear design stuff that we've been working on. Okay. So, so just kind of know that that's there. Remember, you still have some flexibility. If you can't get it all in by tomorrow, end of day, 11:59, you still have an entire 7 days a week in order to get that in. Okay. So, and you don't have to ask for that, if you would, that 7-day grace period. Just make sure that you're getting it in, and then we'll kind of proceed on. All right. Any questions calendar wise? All right. So then what we're going to do is I'm going to go into our course. And the resources that we have here for module number 1, you'll notice that we have our learning plan here. Now, the PDF here is of the PowerPoint, but I'm going to continue in the book here because there's just a couple more things that we're going to be doing in terms of examples and such. So, so we're kind of at the tail end of that. So I'm not going to pull the PowerPoint up at this time, but it is your guide through the chapter for the sections that you would be responsible for. What we will be referencing is we are going to be looking at the Browning Spur Gear catalog pages here. This is not their full catalog, but the catalog pages that would pertain to the problem that we're going to do, the example problem that we're going to do, and we're going to actually be using Browning catalog spur gears to specify the spur gears for our application. So we're going to deviate a little bit from the book, because I want you to get used to using vendor catalogs. Okay. So, so we'll be referencing that a little bit later. And then what we're going to be doing is we have 2 more example problems to finish up here. So, 9.4 is what we're going to be looking at initially here. That's on page 389. Again, that's a continuation of 9.3. And then we're going to do a nice fresh start to finish 9.7. That's going to be a complete design where we're going to be picking our gears then out of that those Browning catalog pages. You should have already gotten your spreadsheet from downloading it here. And then, as you know, practice problems wise, they're really just going to be showing me that you followed along and you did the example problems with me in class. So I've been kind of pointing out where to take screenshots so that you can put them into a document. So we'll continue to add to that document with example 4 and example 9.5. Excuse me. And then before we're officially done today, we will look at that assignment number 1 to make sure that you understand what's expected there, as well as line it up with some of the work that we've done in the example problems during our lecture, so you can know what you can reference. All right. So what I'm going to do is I'm going to go underneath my screen first, or underneath my document camera. Okay. And here. And where we are starting is going to be, like I said, on page 389. Okay. Now 389 is where we have example problem 9.4. Now example problem 9.4 is going to continue from example 9.3. So example 9.3 looked at calculating the bending stress for the example that was kind of started there. Okay. So we went through and we were looking at different tables, different charts, and filling in the numbers that were then specific to the application that they described. And we went ahead and we found on our spreadsheet, I'm going to bring that up here. On our spreadsheet, this is the values that we filled in blue. There are some that are open yet that we will be going back as a part of this part. But we filled in right now, we have this to the point of we know what our bending stress is. Now remember, the bending stress on a gear tooth is due to that tangential force pushing on that tooth, transmitting that force from one tooth to the other. And it's like that tooth is a cantilever beam and it's wanting to push over. Okay, so we need to know what is that bending stress there so that we can then make sure that our stresses aren't too high for the material, the steel material that we're going to be using for this. Okay, so first we have to calculate these stresses. So we've got our bending stress. Now what we're going to do is we're going to find out now what is the pitting stress for the same application. Remember these two stresses. This is the big deal that we want to know in gear design. We want to know what is the bending stress and what is the pitting stress. Now, last time we talked about it. Why do I want to know these two values? And I'll look to my chat to see if anybody puts anything in there, or if you're virtual, you can also just like yell it out if you want. Why are we interested in these two stresses? Yep, they cause wear. Now, wear is considered what? Starts with an F. I know. I'm asking you to fill in my sentences or think like I think. Not fatigue, not force, failure. Okay. When we have wear on the surface of the gears and it starts pitting away because they're hitting one another, that's considered a failure. Okay, so pitting stress, that's a failure. What our pitting is a failure, and we can determine what that pitting stress is by these calculations. What about bending stress? What kind of a failure would too much bending cause on our teeth? Yes, it would shear them off. And that's something that, that can happen. That can happen over time as well. Maybe it just wears out. I mean, everything mechanical has like a life, right? So as long as we get out the life that we're anticipating for, we're designing for, this to have a certain amount of cycles. We're going to find out a little bit later, but we want to make sure that it's going to make it there. As a company, we want to make sure that what we say that our gear is going to do, we want to make sure that it is going to at least achieve that and hopefully even exceed that. And then that's where you start getting into the boundaries of, over designing or under designing. We want to make sure that it does exactly what we're saying it's going to do, but we also don't want to like crazy over design it that then it's going to last forever and maybe it never wears out and then they don't come back and buy our product again, potentially. Isn't that kind of what you were doing, Ryan, when you were at Milwaukee Tool-ish?
Sometimes,
yeah. Yeah. Because everything has a shelf life. I find as a homeowner, my water heater is almost like clockwork. It says it has a shelf life of 7 to 10 years, and pretty much at that 8-year mark, yep, there it goes. I'm going to need to replace it. We have 4 people in our family. We have some, not teenagers anymore, but younger 20s. So, our water system is getting a workout. We do dishes every day. We take showers every day. But seriously, they've got it figured out. It's not lasting, 20 years. It's lasting that 7 to 10 years that they're saying, and then it's just time. So you're going to notice that with certain types of things. And in this case, we're going to talk about, and we're going to be filling in our cycles. So we have to know, what to expect. So we're going to be finishing up this problem. We're going to be looking now at the stress caused by the contact or what's going to be causing pitting on that surface. That's what example 9.4 is. Now going back underneath, you're going to notice right before this problem, they have the equation for that pitting stress, okay? And you'll notice that most of the variables there we used for bending, okay? So the ones that I don't have highlighted, we've already been looking at. So you'll notice that for this contact stress, so this stress C is called contact stress, but they also refer it to pitting. Pitting and contact stress are the very same thing. WT is going to be that tangential force. That's the one that's pushing on that surface each and every time as it engages with that tooth and it's transmitting that force. So that's going to be part of, what we're interested in. KO is an overload factor, size factor. The M, that was the, not the dynamics factor is V. The M, K, Low distribution. Thank you very much, MachEl. Now, underneath, we have capital F. Do you guys remember what capital F was? It was the face width. Nice. So face width is going to be that line for which we're going to distribute that WT, that tangential force. So the wider that tooth is, the less stress we're going to have. Okay. And we're going to find out that, you know, as we look in our catalog, especially in a little bit, we're going to see that as our teeth get larger, or that diametral pitch gets smaller, we're going to notice that we widen out that face width, because we're going to distribute that force over a longer distance. And then you'll notice down here is that diametral pitch as well. So the two values here that we haven't encountered yet are CP and I. So I is called a geometry factor. This is going to be one for pitting stress. So we're going to be reading this one off a chart, and it's actually going to be read off of a chart that's on the very previous page here. Okay. So on page 388, you're going to notice that we have two charts. The top one here is for 20-degree pressure angles. The bottom one is for 25. So we're going to be focusing on the 20. Now, to get this, this value for this geometry factor I, we need to know what the gear ratio is on the bottom here, which is part of what we calculated in the top portion of our spreadsheet. And then we need to know what the number of teeth are on our pinion. Now, they don't have every one of them, so you're going to have to kind of assimilate here. But for instance, for 16 teeth, and we line up our gear ratio, we simply find that intersection and we go over and we read our geometry factor. Okay. Now, CP is going to be a value based on the materials that are going to be used for the gears. I don't know what the chart looks like. There's so many charts in here. CP value, hold on. It's a little further this way. It's not. I wish they would just have a section where they all were, but
I'm pretty sure it's 387.
387. Thank you. Thank you. Thank you.
Down on the bottom.
Yeah. Yep. There it is. There it is. Thank you. So this is called the elastic coefficient, CP. And what we do is we find the material of our pinion. In our case, we're going to be working with steel gears. And then we find the gear material of the gear. So where those two come together, steel and steel, we're going to be using that number. So if you would have different, materials coming together, or, just different materials in general, this number would change. So ours is going to be 23 because we're assuming steel gears. Okay, so that's going to be the CP factor. So you're going to notice we just have a couple more things to fill in on our spreadsheet, and then we're going to be able to find our contact stress. So let's go to this example and just kind of see where we're at. So you'll notice that it says compute the contact stress for the gear pair described in problem 9.3. And then they have the data that we collected from 9.3 is what we see here. So this is all familiar. Now, if you didn't save your spreadsheet, and I hope you did, you're going to want to fill these values in, the ones that we did from yesterday. So our horsepower, the number of teeth, or I'm sorry, the input speed, the number of, or the diametral pitch, number of teeth on our pinion, and so on. Anything that's in blue here. So the ones that we need to add are going to be the I and the AV. So I'm sorry, the I and the CP, and then also we have to add our AV number because we might have added that yesterday, I forget, or the other day. It's 10, right? Because that was given in the original problem. So if you don't have it, put it in there. Now CP, as we saw earlier, I'm just going to review and go back underneath, but we have two steel gears. So steel on our pinion and then steel on the gear. So it's 2,300 for our CP value. So 2,300. And then you're going to notice we're going to go down to this I, the pitting geometry factor. And we're going to now use that chart on page 388 to find our value. So we need our gear ratio and the number of teeth in our pinion. So I'm going to go back up here and we're going to go to the computed data and we're going to find our gear ratio. Our gear ratio is 3.5 and the number of teeth on our pinion is 20. So we're going to go back underneath here, I'm gonna go down so we can fill it in. We're gonna find it on our chart. So we're gonna find where 3.5 is in between here. And we're gonna go up to, well, 20 is not on here, right? So 20 is below or in between these two. So probably right in between those two. So I'm gonna kind of go down, follow both lines. And where I get to about 3.5, I'm gonna say right about here in the middle. Okay. And then we're gonna go over and it's gonna be right about here. Okay. So if we look, that's gonna be 2, 4, 6, 8, 10. So 2, 4, 0.125-ish. Let's see what they used in here. So if we look, oh, I'm sorry, 0.108. Let me, oh, yeah, that makes sense. 0.1 and then 2, 4, yeah, 8. That's what they picked. So 0.108. I was going to the 100th place instead of to the 1,000th. So in my spreadsheet then under I, 0.108. Okay. Now we're going to go down and we're going to see if there's anything else that we need to fill in, or we're going to go down over here and you'll notice that our contact stress numbers are here. Now, there are some fields that we need to fill in and we'll go back to that. But right now, our stress number is right here around 100,000 for our value. In the book, it's 107.69. But again, there might be some differences a little bit in rounding as they did theirs manually compared to our spreadsheet. Okay.
Table 9.7, that last coefficient. I don't know if it's just me, but like, how do you read like?
Yep. So down this column is what the pinion material is. Down this column right here. So that first column is just the pinion material. And then all of these underneath the gear material are the options for gear material. So then steel is here and here. So they come together at the 2,300.
And the one below
it would be metric. Mm-hmm. Yeah, good question. That's okay. And then, like I said, they're spread out all over this chapter because they do a little explanation and they show it. And so I encourage you to go through each one, but it is sometimes a little bit, I don't want to say hard. It's not hard to follow, but it's not convenient. It's not convenient. So now we do have our hitting stress numbers. Okay. And these are going to be the two values that we're interested in. Okay, now you'll notice that we do have some things that are not filled in. So in this case, you're going to notice that we don't have the reliability factor. This is going to be when we start looking at quality wise, how many failures do we want, you know, in 10,000 or 100,000? And there's a chart we're going to read. They didn't go that far with these two examples. The next one we're going to be looking at is what are we expecting our design life to be in hours? We'll be adding that in the next example that we do. And then we're also going to be adding the number of load cycles. Okay. So I'm just going to put some numbers in here, kind of building on what's here, but we already completed example 9.3. So, so I'm going to put in a factor of 1.25. We're going to put in 20,000 hours and we're going to say 1 load cycle. Now what happens is we start looking at additionally the number of load cycles on the pinion and the number of load cycles on the gear. So if we're expecting 2,000 hours or 20,000 hours out of this particular application, you're going to notice that the number of load cycles on the pinion is going to be 2 times 10 to the 9th. So what is that? 200. I have to do it. Is that 200 million cycles? So it'd be 200. Yes, 200 million cycles. So it's going to be 2 times 10 to the 9th. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually 2 billion. Is that what you guys got? Now, over on the right-hand side, if we exceed 10 million cycles, we need to add some additional numbers, and that's what's going to be down here. So in this case, if I want to get 20,000 hours out of this, I need to add a little bit more information. Okay. So that's what we're going to be looking at. So the KR, the L, the Q, and then these Z and Y factors, we're going to be finishing up in our next example, which is 9-7. Okay. So I'm going to take KR out of here. I'm going to take the life out, and I'm going to take the Q. So even though we didn't get all the way down to the bottom between examples numbers 3 and 4, on our very next problem, we are. All right, so we will be finishing it up, if you would, with these adjusted values. For right now, they just wanted to know the bending stress number and the pitting stress number. So what I need you to do then is to identify this as example problem 9-4, and then take your screenshots, and probably, 2 screenshots is probably appropriate. Again, one for the top, and then one for the section here, and then maybe even a third, just so that I can see it, for our pitting stress number, okay? And add that then to your practice problems document, so that you get credit for this, okay? Sure. Okay. Now, once you get that done, if you wanted to save, and I would suggest saving this as, example problem 9-3, so that you have it just in case it doesn't come through or doesn't get submitted. You don't have to redo it all. But then once you have it saved, what I'm going to encourage you to do is erase the values in blue, because then what we'll do is we'll start over, and we will do a new problem. Don't do the KM, that's a calculated value. Okay. And I think that's it. And then just make sure that everything down at the bottom is good. Or if you saved like a clean copy somewhere, you want to bring that up. So that's example 9-3. Any questions on that? I am going to stop recording for a little bit, because then I want to get example 9-7 by itself.